I think the heart and soul of the mean value theorem should be accessible to just about everybody, right down to Algebra 1 students. So consider the function f of x. I'll draw that in the first quadrant. I'll draw it from x equals a to x equals b. And I'm going to label this point right here the point A, and this point the point B. The mean value theorem says there'll be at least one point on the curve such that the slope of the tangent line at that point is equal to the slope of the line going from point A to point B. So let's consider that line. Here's the line going from point A to point B. And the mean value theorem says that at least one point on the curve, the slope of the tangent line to that point will be the same as the slope of this line. We would think of the slope of this line as the average rate of change from A to B. So here's that slope of that line, and you can see that right here, the tangent line would be, the slope of the tangent line would be equal to the slope of that line. Those lines are parallel. And also right here, same thing. So the mean value theorem says that there will be at least one point on the curve such that the slope of the tangent line is equal to the average rate of change from point A to point B. That average rate of change is the slope of the line going from point A to point B. That is the heart and soul of the mean value theorem. But for calculus students, we definitely go a bit further than that. And a calculus student would be asked would be mainly asked this one question: find the x coordinates where the slope of that tangent line, this x coordinate right here, and this x coordinate right here, is equal to the slope to the average rate of change from A to B. So this point right here, point A, the x coordinate is A, f of A. I'm sorry, the x coordinate is A, the y coordinate is f of A. And this point right here, B, the x coordinate is B, and the y coordinate is f of B. So the slope of this line, we know the definition of slope is the change in y over the change in x. So that slope is equal to f of B minus f of A divided by B minus A. And we know from calculus that the derivative evaluated at x is the slope of the tangent line to the curve at that x coordinate. So f prime of x is the slope of the tangent line to the curve at any x. You just plug in that value for x. So what a calculus student would do is set f prime of x equal to this value and solve for x. And that's, I think, 99% of the questions asked regarding the mean value theorem will ask you to do exactly that. Is find the x coordinates where the slope of the tangent line is equal to the average rate of change from A, f of A, to B, f of B. And that's it. That is the mean value theorem. But there are a couple of caveats or some details that we have to look at in order to justify using the mean value theorem. So the mean value theorem doesn't just automatically apply every time. First, we have to state a couple of things, and that is that f has to be continuous on the closed interval AB, and it has to be differentiable on the open interval AB. So, and why is that? So let's consider a couple of curves that go through A, f of A, or a couple of graphs that go through A, f of A, and B, f of B. First one will be continuous, but not differentiable on the entire interval. And I can draw that switch to red. I can draw that just like this. It goes here, and it goes straight up like that, and then it goes down like that. And I think it's clear that at no point on this curve is the slope of the tangent line equal to the slope of the line connecting A and B. The slope is constant this value, and then it's constant that value. And at this peak, it's not differentiable. So that's an example of a curve that is continuous, but is not differentiable. So the mean value theorem doesn't apply there. So remember, you have to state the hypothesis first. You have to say the hypothesis holds true. And that is that you have a function from A to B, and the function is continuous on the closed interval AB and differentiable on the open interval AB. So this is one that isn't differentiable on the interval, but it is continuous. Now I'll draw one that is differentiable, but isn't continuous. And that would be this. Goes down to there, and then from there, it goes like that. So the slope of this line and the slope of this line are the same slope. So it's differentiable on the entire interval, but it's not continuous. And once again, you see that the slope here and the slope here are the same, and neither one of those slopes is the same as the slope of the line connecting A to B. So this is an example of a curve that is differentiable on AB, but is not continuous on AB. So the mean value theorem doesn't apply. The mean value theorem only applies when f is differentiable on the open interval and continuous on the closed interval. Once you assert that, or once you go over that and say, yes, it is differentiable on AB, and yes, it is continuous on AB, then the mean value theorem applies, and you can find the x-coordinates where the slope of the tangent line is equal to the slope of the line connecting A and B. And that's the entire mean value theorem. Again, I think that the people taking Algebra 1 can see that. They can see the heart and soul of the mean value theorem, but they may not be familiar, at that level, you might not be familiar with slope being the rate of change, or slope being the average rate of change from one point to another point. And they may not be familiar with this kind of notation. And certainly they're not familiar with taking the derivative of the function f. But you calculus students, I think, should understand all this, and it should be completely clear. So that's it. If you have any questions or anything, I would be happy to hear from you. And thanks a lot for spending the time watching. Thank you.